All right, ladies and gentlemen, here it is. Remember, you can pause me anytime you need to, and you can skip parts if you don't want to look at them. So, first question is exercise 10, practice exercises, is about Billy Joe standing on a bridge. So, I'm going to draw my Billy Joe over here and put him kicking a stone off a bridge woo, into the water. So, we have there the water. And we're told that it has a horizontal velocity. So I'm going to use blue to show horizontal 3.5 meters per second. And it lands in the water a horizontal distance, which means from here out to here, of 5.4 meters from where he's standing. And they want to know the height of the bridge. So they want to know the dy. So things we know, x and y over here. We know that gravity is going to interact. It's going down, so it's 10 meters per second squared. Its initial speed is 0 meters per second. It is a distance, so that's what we want to find. We know on the x side, we know the speed of 3.5 meters per second, and we know the distance of 5.4 meters, so we should be able to find time. The only equation you can use on this side is v equals d over t. This is the only equation that can be used on the x side. So we can say 3.5 equals 5.4 divided by t. When you do the algebra, you should find out that t equals 1.54 seconds. Since this is the time here, we can also plug it in on this side, and this would be the time it took to fall. If we know this, we can now find the dy by using the equation dy equals v naught t plus 1 half at squared, where a is our g. If that's the case, we know that this is 0, so this gets canceled out, plus we get our 1 half 10 times our 1.54 squared. And when we do the math, you should find out that your dy is 11.86 meters. So that's your height that the bridge is. Now it asks if you make this right here a larger number, the 3.5, if it's a larger number, then what will happen is you'll eventually do 5.4 divided by something like 4. If that's a bigger number, then that's going to make your time smaller. So if it shortens your time, then that would be the answer to B. Okay, so time is smaller or shortened. Okay, we have the information about the plane, and the plane has it to where we are at an altitude, so that means it's this high, of 500 meters. And it also says that it lands 400 meters, so this is the 400 meters. And it wants us to find how fast the plane is flying. So it wants us to find the Vx. Because remember, the rule is that the object will have the same speed as the moving object that it fell out of, the same horizontal speed. So when we set up our xy, we know that gravity, 10 meters per second squared because it's falling down. We know the initial speed in the vertical is 0. And we know our distance to be 500 meters. We should know that the time here is going to equal the time here. And then we also know that this has a dx of 400 meters. And we want to find the vx. So the first thing to solve for is our time. Now on this side of the equation, or on the y, you can always use this formula. You cannot use this formula on the horizontal side. So this can only be used on this side of the t-bar, okay? So we have 2 times our 500 divided by our 10 square rooted. This gives us a time of 10 seconds. So that would also mean that this is 10 seconds. Okay. Now, on this side of the equation, or on this side of the t-bar, or on our horizontal vertical information, V equals D divided by T is the only formula that can be used. All the other formulas are used on the other side. This is the only formula that can be used on the X side. So if that's true, we now have 400 divided by 10 seconds. So that would give us a speed of 40 meters per second. And that is the answer to number 11. On number 12, we have the cherry pit being thrown out of the car, and the car is moving at 18 meters per second, so that's the horizontal speed, and the window of the car is 1 meter above the ground. They want to find out, where's the cherry pit going to hit the ground? What distance is it from where it originally was thrown? So when we set up our X and our Y, down here, we know that gravity equals 10 meters per second squared because it's falling out of the window. We also know our distance is 1 meter for our y. We know our initial speed is 0 meters per second because we're just talking about half of the projectile. So its initial speed 0 because it's going to gain speed as it falls. And then we could solve for time here. If we needed to, then whatever the time is here will be the time here. We also know the Vx on the horizontal side is 18 meters per second, and we want to solve for the dx. This is what we're mainly solving for. So let's talk about this x of the t real quick. Okay, so if that's the case, I can solve for t equals the square root of 2d divided by g. Remember, this can only be used on the y side of the equation. Okay, so 2 times 1 divided by 10 square root would give me a time of 0.45 seconds. All right, so if it's 0.45 seconds here, it's also 0.45 seconds here. All right, then what the formula that I said you could use on the x side is only this one, d divided by t equals velocity. That's the only thing that can be used on this side. So that would mean that to find d, it would be v times t equals d. So 18 times our 0.45 seconds equals d. Okay. And if that's the case, then we would get an answer of 8.1 meters. Now it asks, if you keep traveling at this same speed, where will the car be in relationship to the pit when it lands? It's going to be in the same spot. They're both going to be at 8.1 meters. Because if you go back and look at the airplane problem in the in the PowerPoint, look at the dropped package, and if the airplane just keeps going, when the package hits the ground, where is the airplane? It's directly over it. So they're going to be in the same spot. All right, number 13, we're talking about the frog jumping from lily pad to lily pad and the distance between the lily pads. So your dx, let me get the right color. My dx is 2.4 meters. And my total time up and down, so my total time is 0.6 seconds. If I know this, I should be able to find my speed in the x position by taking d divided by t. So 2.4 meters divided by 0.6 seconds. All right. Because on this particular problem, we're actually trying to just solve for this angle right here. That's all they want me to solve for. But by doing this in the x-axis, I can find out that the speed, the horizontal speed is, or the horizontal velocity is 4 meters per second. So that means right along here that it's 4 meters per second. If we redraw this triangle, we now know this is 4 meters per second. We know that he's launched at, or he jumps at 5 meters per second speed. And so we can find this angle because we have the adjacent and the hypotenuse. So the adjacent and the hypotenuse is cosine. So to find the angle, you take the inverse cosine of your adjacent, 4, divided by your hypotenuse of 5. And that should give you an angle of 36.87 degrees. And that would be your answer, and that's to the lily pad, because I just want to know what angle he jumped at. Okay, at number 14, we have Jennifer the bride who's throwing her bouquet. And she lined her girls up differently than most weddings, and I have them listed here in what way they lined up. The things that you need to realize is you have this triangle going on. Okay, you have a 50-degree angle here and you have 3.9 meters per second. You also know that the total time that the bouquet is in the air is 0.6 seconds. So we can find the Vx right here by doing Vx is the cosine of 50 degrees times 3.9 9, and we should find out that that speed is 2.5 meters per second. If we know that, we can now find the distance because we want to find what distance this went to see who catches this. And we don't know how far this went, and that's what we want to find. Okay, but we can say Vx times t, and that would be 2.5 now times our zero point 0.6, and we would find out that it's like 1.5 meters. If that's the case, who's at 1.5 meters? Well, Kendra is, so she's going to catch the bouquet. And then it says if we now slow down this speed of 3.9, that's also going to make this speed, actually right here, this 2.5, lower. And if it lowers that, who's going to catch it? Well, if that's lower, then that's a smaller number, and that's a smaller number. So if this is a smaller number, who's going to catch it? Well, then that would be Kelly. So on this, A was Kendra and B would be Kelly. All right, if we drop the flour sack out of the airplane, it's going to have a horizontal speed of 60 meters per second, so I listed that under the X. The time it takes to fall is going to be the same time as it takes to go across because we're just dealing with part of or half of a projectile. It's 300 meters up, so that's the dy, and gravity so is 10 meters per second squared. So we can solve for t by taking the square root of 2d divided by g, which would be 2 times 300 divided by 10, take the square root. So your time ends up being 7.75 seconds. So this would be 7.75 seconds as well. And to find dx, we use our v times t. So that's going to be 60 times our 7.75. All right. And when you multiply those two, you should get 465 meters away. That's how far away it's going to be. Notice these are our blues, and this is our reds. Okay. And then this time gets to be placed here because it gets to go on both sides. All right. On 16, we have a 0.25 meter candle, and we know that he's launched with 5 meters per second speed at a 30-degree angle. So we could find our Vy right here. And if we did that, we could say our Vy equals our sine of 30 degrees times our 5 meters per second, which would give us an answer of 2.5 meters per second. Well, if that is our initial speed, let's say, and let's say our final speed is 0, and you can do this either direction, doesn't matter, then we're going to say that gravity is a negative 10 meters per second squared. And we could do our Vf squared equals V naught, squared, plus 2AD. And if our final is 0, squared equals 2.5 squared plus 2 times a negative 10d. We then are going to get our negative 2.5 squared divided by negative 20, which would give us an answer of 0.31 meters. Now you take this answer right here, your 0.13 meters, and you compare it to the 0.25. Since it is more, he'll clear the candlestick. So he cleared and not burned.